In this video, we're going to find the partial derivatives with three independent variables. So let's try and do it with respect to x first. So here you've got one block multiplying another block, and then you've got this block multiplying with this block multiplying with this block. We're trying to find the partial derivative with respect to x. So this is a variable, this is a constant, this is a variable, this is a constant, this is a constant. So when we differentiate this, it would just become, with respect to x, it would just become cos of z, and then plus, and then remember this is a constant. So when we differentiate it with respect to x, the 2 will come down here, so that would be 2x, and then everything else after that. So that would be 3 y to the power of 3 z e to the power of z, e to the power of z, e to the power of z. So that would be your partial derivative with respect to x. So now let's do it with respect to y. So you've got one block multiplying with this block. With respect to y, this whole thing here is just a constant. So when you differentiate it, it would just be 0. It would just be 0. And then with respect to y, these two are constants. So when you differentiate it with respect to y, the 3 will come down, so that would be 3y squared, and then everything else after. So it would be this. These are just constants. There. So that's with respect to y. So now let's do it with respect to z. So z, hang on. So with respect to z, this block here is a variable. This is a constant. Constant, constant, variable. Oh, hang on, bear with me. Oh, hang on, bear with me. So this block is a variable, constant, constant. So so let's differentiate it with respect to z. So this is a variable. So that would be, so when you differentiate it, it would be x, because x is a constant. So that would be sine minus sine of z. There. And then differentiating this with respect to z. So this is our variable here. So these two blocks will be a constant. So it will be plus x squared y to the power of 3. When you differentiate this, it will just be e to the power of z. So that's your partial derivative with respect to z. Okay. Next example. So let's try and differentiate this with respect to x. So here you've got one block multiplying with this complicated block here. With respect to x, this block is going to be a variable. This block here actually, the whole block itself is a constant. It doesn't contain x. It doesn't contain x. So this whole block here is a constant. So when you differentiate it with respect to x, this is a variable here. So when you differentiate it with respect to x, it would just be cos y plus 3z. Okay, because it's like me asking you to differentiate x 7 or 7x. When you differentiate it, it would just be 7. Well, anyway, differentiating this function with respect to x will give you this. So now let's do it with respect to y. So this block here and this block here. This block here contains y. So it's a this block here is a variable. This is just a constant. So let's just concentrate on this. This is a constant, remember. So when you differentiate this block, it would be minus. It would be minus sign. So it would be minus sign. Remember, the x stays the same. Minus sign. Minus sign. The bubble stays intact. Y plus 3z, and then times the derivative of the bubble itself. We're using the chain rule. So with respect to y, so when you differentiate the bubble, remember the bubble inside the bubble is just y. That's a variable. So that would be, when you differentiate y, it would just be 1. Okay, so let's forget about the 1. So now is that right? Yeah. So when you differentiate this with respect to y, it will then give you this. Now let's do it with respect to z. So you've got one block multiplying another block. This block here doesn't contain z. It's just, that means it's just a constant. So now this block here, you've got a z here. So so this block here is going to be a variable. So let's differentiate this. So this is a constant. So differentiating it with respect to z, it would be the x stays the same. Differentiate this, it would be minus sine, the bubble stays intact, and then times the derivative of the bubble itself. Remember, this is the bubble itself, and y z is the variable, y is a constant. So when you differentiate it with respect to z inside the bubble only, it would just be 3. So times 3. So if you tidy this up, it would be negative 3x sine y plus 3z. Okay.